video. It's pretty blurry.
It's what?
At least on my side, it's pretty blurry.
Yeah, it's
Not in focus. Did you forget to take the plastic off the lens?
depth of focus is not that big.
Oh, okay.
Okay, so let's go to screen. And let's full screen. Okay, I hope everybody can see the slides. And so this month, nobody stepped forward. Well, one person stepped forward to present, but it won't be this month. It'll be a future month. So I decided to pick out a topic and talk about it for this evening's presentation. And I picked hopefully something that that you folks will enjoy or find interesting. If you're not part of the contest scene, I know a lot of people participate in field day. Technically, field day is not a contest, but it's an event. But a lot of people do treat it like a contest, and there's lots of contesting aspects to field day. But I think we'll try to separate a little bit from that style of contesting to maybe we could use the term professional contesting, perhaps, as a pseudonym. So I wanted to talk about, in general, the really big stations. So the stations that are scoring #1 in CQ worldwide, or the station that wins sweepstakes, or the station that wins the worldwide RTTY contest, those kind of stations. So what are they? A lot of those are what are called multi stations, or in some cases, another category is single operator 2 radio stations. And this is just this picture is just one example that's actually close by. You can actually go over to Wickenburg, and if you turn north off of 93, like you're heading to Congress, as soon as you make that turn and you clear the little rock pile on the left, on the west, if you look out towards the west, just after you made that turn, you should be able to see Tim and Dan's contest station out there in the distance. I don't know, maybe a half mile away, a quarter mile away. They have 4 different towers set up out there with a myriad of antennas. So let's get into a little bit more detail. So a few questions that I posed were, well, what is a multi and what is an SO2R? And then how do you prevent interference? And what I mean is not how do I prevent interference with maybe television or radios that, broadcast radios or any of that sort of thing, but how do you prevent interfering with yourself? So you have an operator on 20 meters, you have another operator on 15 meters, and maybe a third operator on 40 meters. How do you make sure that all those different stations that are co-located within probably 200 or 300 feet, their antennas, how do you keep all those stations from interfering with each other during the operation, during the contest? And then what about switching networks? How do you prevent, or what about unintentional transmission directly into another adjoining receiver? You don't want to be running 1500 watts and then dumping that directly into the next guy's radio receiver and blowing up his radio. So how do you separate those kind of things and make sure that mistakes aren't made? We'll talk a little bit about that. And then a little bit about bands and modes and how that how you can practice single operator 2 radio to operate to be the only operator running two radios simultaneously. And the only stipulation is that you're only allowed one transmitter. So you have to alternate your transmissions between the two different radios. And how does that work? And how can you practice to do that to increase your contact speed? How many contacts per hour that you make? And then some final tips and takeaways that I hope you can get from this. So W2RE, Ray, he's up in Maine. He actually has his own business called Remote Ham Radio, and he basically leases out. This is just one example. Jonesport. He's got like a 200 or 300 foot tower with a bunch of stacked beams on it, and you too can use that radio in antennas if you like. So, what do most of these contest stations run for equipment? So I put on the perhaps the most popular radios that are used. Of course, the Flex 8600 just came out, so people are currently using for these contest stations the 6600, and in some cases they're using the older 6700. If you're familiar with the Flex radio systems, their equipment. And what I've seen is a lot of stations use either the Flex, the L-Craft, or the ICOM series of radios. There doesn't seem to be too many contest stations that are using the Kenwood or the Yaesu. Some contest stations do use the older Yaesu, the FTDX 5000, but the 101D is the most recent high-end radio for contesting. But you don't see a lot of them at contester setups. The most important thing is, why don't we see the 7300, ICOM 7300, as one of the radios? Well, the main reason is that it does have two receivers, but you can't listen to both sides simultaneously. So you can switch the VFO back and forth. So you have two displays, but you can't hear both sides of the conversation at two different frequencies simultaneously. And that's what all these radios do. They basically have two independent receivers. Well, in the case of Flex, you get 4 independent receivers, but you have at least 2 independent receivers, and then of course 1 transmitter. And that offers you a huge advantage when you're trying to work single operator 2 radio, or even if you're trying to work split. It makes it much, much easier if you're trying to work split and you can hear both sides of the conversation and then just dial the VFO around and move it a little bit, listening to the pileup that's calling the split station, so that you can track and figure out, oh, he just made contact with this guy. Oh, and he's moving up. He's up another KC. Oh, he just moved up 1.5 KCs. And so you can figure out their pattern. And then the next time when you want to call him, you move your split frequency to where he's supposed to be at the next call, so that you can jump right in there and get him ahead of everybody else. So that's part of the game. So I thought I'd share at least a few examples of some of these contest stations. In the upper left is Tom, W8JI, over in Georgia. He has a pretty good sized station. He's got like a 315 foot tower and a couple of 200 foot towers and a bunch of antennas, a lot of beverages. On the far right in the upper corner is the entrance point for Tom's myriad of antennas that are coming into the shack. And the first thing you might notice is that there's this giant copper plate right at the entrance where all the coax is coming into the shack, and all the rotor cables are coming in, and all the antenna switching it all comes in right there at that location, and it's all grounded together, so that you don't have if there's a lightning strike, and let's say it's on the corner of your property, the antennas that are closest, they'll get a voltage spike, and what it does is it keeps everything at the same potential by having all the grounding tied together, so that you minimize the impact to everything. Because what kills radios is, other than a direct strike, a direct strike, you're at the mercy of the light. It's going to do whatever it's going to do. But if you have a nearby strike, what you want to do is you want to keep everything tied together, all the grounds, so that you don't get a voltage differential between one antenna system and another, because that's what'll blow things up in the shack. When you get that voltage difference, because you have two different grounds. And so you want everything to come in at one point, and everything ties to a ground all together. And so everything in and out of the shack. And down below is another contest station, Craig K9CT. His arrangement looks a little cleaner. But the same idea. Everything that's coming into the shack or going out of the shack is at one central location, and it's all grounded together, so that everything moves up and down in voltage simultaneously when there's a lightning strike. And hopefully that saves a lot of your gear. On the left at the bottom is the 4 stations that Craig has set up for his contest station. And he likes to use flex radio. So he's got a bunch of 6700s right behind the Maestros. And then a computer for each one of those stations. And you can see the amplifiers up on the top. Right, if I can get my mouse over here. Here's one of the PGXL amplifiers. It'll handle 2 different stations simultaneously. So you can run one to this radio and one down to this radio. Same thing is true on the other side, same type of setup. And that all gets connected through cable trays in the ceiling, comes back over to this central panel that goes out to all the antennas. And this is a little small, so the next picture is actually a blow up of that, so we can at least see some of the stuff that's there. And so, we asked one of the questions of, well, how can you keep somebody on 15 meters or 40 meters from interfering with somebody on 15 meters? Because 15 meters is the third harmonic of 40 meters. And so one of the ways they do that is they use a lot of high-powered filters. So each band has its own set of filtering before it goes out to the antenna. And so the signals come from the radios, which are off to the left. They come in on this cable tray, and then they go into this matrix. And the matrix takes in 4 different transceivers, and you can control with the computer which of these 12 outputs it's connected to. And so what it does is it automatically takes care of antenna switching, such that you're not going to connect radio 1 to radio 4 accidentally and blow up one of those 2 radios, depending on who transmits first. So you don't want to be switching things manually. You want to have some automation, some computer control, so that these things happen consistently and quickly, and if it will follow the radio. So if the radio is telling this equipment, oh, I'm switching from 20 meters to 15 meters, it automatically takes care of, when you change the band on the radio, it automatically takes care of the switching for the antenna and puts you onto the correct antenna. So you don't even have to worry about it. it just handles it. Another thing is that so he does have quite a few rotatable antennas. So he's got a whole set of green heron rotators to turn antennas and point them to various parts of the world. He also has some of those antennas are stacked arrays. So 2 stacked antennas for 20 meters or 3 stacked antennas for 20 meters or whatever the case may be. So he has a couple of stacked matches so that he can phase those antennas together properly to get the additional gain from all of them being ganged together. And down here near the bottom, you see this nice big large plate that all the polyphasers are attached to. And just below that, he's got 20 different coax runs going out to various antennas, whether they're transmit antennas or receive antennas. That's some pretty big coax. I think some of these are 1 5/8 heliacs. And I think some of them are, I think some of the smaller ones, like maybe this guy is 1 inch or 1.25 inches. So it's massive cables. Some of the antennas are 500 to 1,000 feet away. So you need to have larger coax to minimize the signal loss, even at HF. You can have some pretty substantial signal loss in the 20, 15, 10 meter bands if you're running 1,000 feet to get from your antenna back to the station. This is just another example. I like this one. Trina and her husband did a really nice job of cable management. You can see that they have all the various switching. They did some nice cable management through here, tied things up nicely, made it look clean. Not a bunch of, man, this hobby takes a ton of wire for a wireless hobby. And I like the way that her and her husband did this setup. It's really nice clean setup. You even got the cable trays up above to carry the cables over to the radios and so forth. And so fella Randy K5ZD Z Delta, he's been really big into doing single operator 2 radio for probably 40 years, since the early 80s. And he talks about how can you prepare yourself to do single operator 2 radio. And what he's showing here is that for a particular contest, the CQ Worldwide CW contest back in 2000, he's just sharing, the difference between the total number of QSOs per hour that you're making versus how many QSOs you're making on the second radio. And it's not a whole lot of additional QSOs. You can see, here he's showing that, well, it's something greater than, say, 12% of the total. But what I think you're looking for in that second radio are multipliers. A lot of contests, yeah, it's mainly about making contacts, raw numbers of contacts. But if you can pick up additional multipliers, so in some cases, maybe the multiplier is every DXCC entity that you work is another multiplier. So if you've made 500 contacts and you had 100 DXCC entities worked during the contest, then you have 500 times 100 DXCC entities, your score goes way up. And so for each additional multiplier, you can really start boosting your score. And so I think that's what a lot of guys use the second radio for, is to do searching. They're running on one radio. So you're calling CQ and you're working, station after station after station, back to back to back on one radio. And the other radio, you're listening in the background. You know, you have a set of headphones, and in one ear, you're hearing the main run station that you're doing all the calling. And in the other ear, you're hearing the secondary radio, and you're scanning for those multipliers to pick up those additional points. So this is how Randy set his station up, one of his stations at when he was in Ohio. And so he's got, in this case, he's got two K3s, L-Craft radios. He's got a set of bandpass filters, 6 of those that are automatically switched, so that he doesn't have to worry about switching when he switches bands. He's got one set of headphones and keyer and a computer tied to both radios, so that he can control both radios through the computer, do logging for both radios, and manage his connection, his physical connection to the microphone or the CW keyer to make contact. And then he's got a couple of amps behind the radio, because most contesters run legal limit, maybe more, but at least legal limit. And then that goes into a switch, another one of those switch boxes. And looks like in this case, he's got a 2 to 8 switch box. So he can switch in either radio and connect it to any one of 8 different antennas. So he, and this is pretty much seamless. The micro ham controller that connects the computer and his keyer and his headphones and microphone pretty much handles all the connectivity and the changes. All he has to do really is change the VFO, you know, spin the dial, and everything else is pretty much automated. He doesn't have to worry about it. And so this is Randy's his station layout. And he said that he's right-handed. Well, I think a lot of people are right-handed, but I know there's a few lefties out there. But so for Randy, he deliberately put his rotator controllers on the left-hand side of the screen, because when he's sending CW, you can see on the right-hand side, he's got his CW paddles down here. So he can be sending CW, reaching up and changing the direction of the antenna while he's sending. And he's got 3 different rotors there, 3 different controllers, different brands. And he's got 2 radios. We've got a K3 on the left and a K3 on the right, both of them with PAN adapters. And the amplifiers are a little bit out of the picture, but there's one above this radio. There's another one over here, another Ameritron off to the side. And the other key thing is on the right-hand side, that's where he has all his different antenna switching controls. And that's, he deliberately put it on the right-hand side because he wanted to minimize the chance that he would be sending or transmitting while he's changing antennas, changing bands. And so when he takes his hand off the key, he reaches up with his right hand and he can make the changes to the antenna, whether it's a 4-square or it's a beam antenna or whatever the case may be. He can switch the antennas without having to worry too much about him transmitting, because he just took his hand off the key. And so he can't send with his left hand. So these little tips. Yeah, the other thing, that the last little tip that he had was, you know, a lot of stations are set up as a straight line. And so like Craig, K9CT station, it was a long table with a shelf above it. And in that case, I mean, for some people that works. But in this case, where you're going to be operating 2 separate radios, you want to have them closer to you. And so by using an L-shaped table, where you're sitting at the focal point, it's equidistance between going to the left radio with your left hand and going to the right radio with your right hand to make adjustments or change things. So it's something to consider when if you'd like to try SO2R. So where do you start? I mean, you know, I have trouble sometimes just trying to get through one station. How in the world are you going to listen to two separate stations and make contacts alternating between them at some rate? Maybe it's not 50-50, maybe it's much less, maybe it's 90-10. But to be able to listen to two different stations, well, one of the suggestions is that, well, let's start with just trying to figure out the flow. So maybe we try to offload as much as possible to automation and to computers. And so RTTY might be a good way to start out, where you're just trying to understand how the flow goes. You know, what is the timing to be able to switch back and forth and make contacts on one station and then switch over to make contacts on the other station, and to let the computer do the bulk of the work where that switching is automated. And all you really have to worry about is watching to see who's being decoded and picking stations that you want to make contact with, and maybe twisting the VFO to tune them in as you move across the band. So it minimizes your workload when you're trying to get started. FT8, that may be even easier than RTTY. You know, RTTY, you're going to have to be messing with the VFO and changing frequency, scanning the band, especially if you're doing search and pounce. You're going to be moving up and down the band, and so that's going to take time, and you have to do that for two radios. So maybe FT8 would be even an easier way to offload more of that work to the computer, and so that you can get used to the flow of how it moves, how quickly things happen. And RTTY is really quite slow. Most people run 45 baud, so the data rate's not real high, so it's probably 30 seconds for a transmission, and you know, then you have 30 seconds of the other person transmitting, so, and you have a couple of exchanges back and forth, so it's a minute or two per contact. Sorry, message popped up. And you can also just listen to a contest and not necessarily participate in the contest, but just get used to listening to two different radios during a contest and try out the idea of maybe working 40 meters and working 20 meters. You're just using the receiver, and maybe once in a while calling CQ on the main band that you want to operate, whichever radio that is. That's totally up to you which band you want to try. And just using the second radio as a search and pounce method of finding stations, trying to find multi-hoppers. And once you start getting better at doing that, you can start making contacts on both sides. So yeah, learning to listen to those two different audio streams and being able to pick out, if you're really good and you can do it with CW, that's even better. To separate two different things simultaneously, one ear and the other ear, and be able to comprehend what in the heck is going on. That's pretty amazing. So perhaps one of the more difficult methods to try to get started anyway with single operator 2 radio is sideband. Even though it's easy from the perspective of communicating for us, you know, heck, we've been speaking, you know, whatever language we learned for the last 50 or 60 years. But you then, as the operator, are the one that controls everything. And so you can quickly become overloaded with trying to make sure which radio am I transmitting on? And is it the first radio or the second radio? And you know, there are some things you can do to make it a little easier. So a lot of these contest radios, even the more moderate radios, like say a 7300, it even has a voice keyer built in. So you can record your voice calling CQ. And so you don't have to spend 24 hours or 48 hours calling CQ and ending up being totally hoarse and you can't even talk by the end of the event because you've been screaming into that microphone trying to make contacts. So the voice keyer is a huge help. It's more again automating some piece of the action of the radio, making contacts. And so it allows you to focus a little bit more. It gives you a little bit easier opportunity to find those multipliers if you're not the one actually calling CQ. It's a recording of you calling CQ. And finally, the last part here, there's quite a bit of, I mean, this is just a few examples. I'm sure if you dig into YouTube, you'll find dozens and dozens and dozens of multi stations, what's going on when they're contesting, and single operator 2 radio operations on YouTube. And some of them are kind of educational. They try to describe what it is they're doing and how they understand the flow and how they try to optimize things to improve their score, to make more contacts. Because that's the whole point of a contest, is how many contacts can you make and copy all the relevant information, the exchange, and how quickly can you do that? How many can you get in the log? So there's lots of resources out there to read about how people have set things up, equipment they're using, enhancements that allow them to offload a lot of that burden from the operator onto some automated piece of equipment to make things more foolproof. So you don't have accidents where you're transmitting a kilowatt into somebody else's receiver and blowing up station 3, blowing up station 2 and making it completely inoperable. So those kinds of things. And with that, I'll leave you with another one of Ray's stacked beam antennas. He's got, I think that's 3 stacked antennas. And then at the very top, he's got, I think that's a 3-element 40-meter beam at the very top. But I think those others are 10, 15, and 20 meters. And they're all ganged together, pointing away from us. And so you get a tremendous amount of gain from doing that. But does anybody have any questions or comments? No questions? Everybody's muted.
So James, when are you going to build your station like that?
Well, that's an interesting question. I was looking at a property out west of here, and on Monday, I discovered that the property immediately adjacent to it on the north side had an active dirt runway. And so I immediately dropped that and decided, okay, we're not buying that piece of property because, as you may know, you can't put up towers right at the end of a runway, even if it's a dirt runway and there's no air traffic control. I think the FAA would look very poorly upon me if there were an accident because an airplane struck a tower. So I'm in the process of looking for someplace to build a remote station. Maybe not as big as what Ray did, but on that kind of order, a couple of towers and several different beam antennas, maybe some four squares and so forth. But I do want to do two sets of radios. So a K4D setup and a Flex 6600, and have those each set up as SO2R radio setups, radio systems.
Hey, James, how does that work when you're online? Because it seems like it would not be quite as conducive to radio.
Yeah, so when you're online, you need low latency. One of the ways that people get around that is you have an on-site computer that controls everything. And then when you're off-site, you use a separate computer, and some of these radios have separate control heads. And so you can control the radio with, say, a Maestro that Flex has, and control the same radio at the remote station. But on the computer side of things, you can use AnyDesk and connect to the local computer at the remote station, and have it has all the software. So you eliminate all that latency, because the computer that's at the station is directly connected with either the radio and the switch gear and all the various pieces. And like if you're running a digital mode, you definitely want all the digital signals processed at the remote station, so that it's quick. So there's virtually no latency involved. Everything's done locally. And if we hear it, on the internet side of things, and it's a second or two slow for us, that's okay. I mean, the computer made the contact. We told it what to do. It's the same with RTTY or PSK31 or FT8. All those modes are basically the same in terms of operator interaction with the radio and the computer. And on the voice side of things, people use UDP? Is it universal? Somebody with computer stuff, help me. What's UDP? It's for sending audio, but if you lose a packet, if you lose a packet, it just drops it. So it only, whatever packets make it to the other end are the ones that get sent. And so if you lose 2 or 3 or 4 packets out of 1,000, you're never going to hear it. Most likely, you're never going to hear it in the audio. So for single sideband or AM communication, they use that protocol.
User datagram protocol.
User what?
Datagram protocol.
User datagram protocol, UDP, rather than TCP/IP, which wants to get an acknowledgement for every packet sent.
They're both IP protocol. They're both over IP. It's TCP is transport control protocol, and UDP is user data protocol, but they both run over IP.
Yep.
Yeah, but there's no connection with UDP.
Yeah, there's no acknowledgement, right, Leonard?
Right, it's a connectionless protocol. It's a shoot and forget.
Yeah, exactly. And so for sideband audio type stuff, that's perfect. Because if you lose 10 packets out of 1,000, nobody's going to know. Or most likely, they're never going to know.
So James, any of these super stations that you've been doing the internet piece on, are they doing that set up for two operator?
Yeah. So you can run most of the stations on remote ham radio are Flex radios. So they're either 6400s or 6600s. And you can run two radios, two receivers, and then transmit depending on which band you want to hop between.
I see.
I got a question, James.
Yeah, sure.
Sure, I'm kind of new to these meetings, but I'm pretty good with ham radio. I'm a retired avionics aerospace electronics technician, but how do you set up, is it free ham radio software for an audio CQ keyer? What is that?
So how do you mean, how do you set up recording your voice? Is that what
Yes,
you're asking?
well, not recording, but like an audio CQ repeater. Is that just like audio recording software and you just play back a sequence? So you don't have to keep screaming into a mic CQ, or is there
Oh, yeah.
special software for that?
Yeah, good question. So there are separate packages that you can, like N1ML. It's a logging program for contests. You can record your voice on your computer and have it call CQ. But some radios will do it too. So all the radios that I showed in the beginning, they all have voice recorders. Even the ICOM 7300 has a voice recorder. And so you can record, I think it's 4 different recordings or 8 different recordings. And so you can have one for calling CQ, one for QRZ, one for a signal report, because everybody in a contest is 5'9". Doesn't matter if they're just above the noise floor at 5'1", they're all 5'9".
Yeah, the 7300 does have 8, James.
Oh, okay. Yeah.
Cool, thank you.
Oh, you're welcome. Yeah, a lot of the older radios, like the Yaesu FT1000, I don't remember if it had voice recording. Maybe Bill, do you know if it has voice recording? Are you still on? He's got one, so he has an old FT1000. I don't remember, but and that used to be one of the top of the line radios. I don't see him on. He must have dropped off. But yeah, all of the I'll say the top line radios, they all have voice recorders, and many of the newer more moderately priced radios like the 7300, the FTDX10, they all have voice recorders too.
You may have to get a mini SD card to put in it for the memory. At least on 7300, I had to put a card in my radio to do it, but I use it all the time.
That's
Yeah,
great.
some of them don't have enough storage, so yeah. Yeah, so it's a lot of fun, and I've experimented, well, before my station vaporized, I was experimenting with doing single op 2 radio, but at the very beginning, just trying to listen to two different stations simultaneously and pick one out of the left ear and pick the other one out of the right ear, and try to remember the call signs, enter them correctly into the logging program. But it's quite a feat to be able to do that proficiently. And the guys that do, they really rack up the points. You know, they get 300 or 400 contacts a minute, or sorry, per hour. 300 or 400 contacts per hour. Yeah, the guys are laughing back here. Yeah, per minute. Yeah. But well, I hope everybody found it interesting. I try to find things that maybe most people haven't thought about, or maybe they have thought about it, but they haven't looked very deeply into it, and try to talk about it and get people's ideas and show what other people are doing. So I hope everybody enjoyed it, and if you happen to know of anybody that would like to come and speak, doesn't have to be about ham radio. We've had people talk about NASA projects. We've had people talk about the HARP system up in Alaska. I know there's a lot of requests for that. I've asked that guy if he would come back and present again, but he hasn't responded. So I probably asked him 4 or 5 times by now. But yeah, we've had people talk about farming equipment. So don't feel that your topic is out of bounds. Any topic just about, we'd love to hear from you and share with everybody else. If you happen to have a ham radio topic, that's awesome. We're all hams here, so I'm sure a lot of people will be highly interested. But don't let that limit you in what you might want to present. And with that, if there's no other comments or questions, thank you everybody for coming. And we look forward to seeing everybody at the next event.
Great presentation. Thank you.
Thanks.
Thanks, James.
You're welcome.
And we disconnect.
Yeah. What do you want? Your Zoom window. Zoom window. Okay. Oh, let me go over here and stop the recording.